back to pages 3 and 4. Okay, so on page 5, we've got a concept. So we're not doing any math on this one. It's a concept question. We've got projectile motion for 2 rocks. We're going to be asked about velocity and acceleration. 2 identical rocks are thrown horizontally. And yes, I'm highlighting that word because in a couple days, we may throw them at angles and, you know, what's different. You want to make sure you know what is happening. And we're going to throw them with different velocities, different initial velocities. They are thrown at the exact same time, and shown below, we pause the video. Here it is a few seconds later. For the instant shown, will the magnitude, what does magnitude mean? Size, number, right? Just amount. Who cares about direction? Will the magnitude of the horizontal velocity for rock of rock A be greater than, less than, or equal to the magnitude of the horizontal velocity of rock B? Now let me direct your attention to phrasing. Does the question say the velocity of A and the velocity of B? No. Be very specific, not only in our explanations, but in our subscripts. You got to tell in this 2D world, you got to tell what velocity, what distance you're talking about. So what do y'all think? A is going to be less than B? Why? It travels less what? A travels a smaller horizontal distance. And so you're saying that the smaller horizontal distance traveled will mean a smaller horizontal velocity? That's only true if they have the same time. So I'm going to say question mark. Do they have the same time? How do you know they have the same time? It just says they're thrown at the same time, right? So we freeze it here. Time, if you think back to our water balloon, it was vertical dependent. And so since they're thrown from the same vertical position, they start at their max height, right? And you pause them, their final vertical positions are the same. Gravity is the same. Initial vertical, what's the initial vertical velocity for these objects that are thrown horizontally? 0. And so, yeah, yes, they do have the same time, okay? And so you are going to see that it is A is less than B, but you can't forget about the time part of the explanation. They have the same time because both have a vertical displacement, an acceleration due to gravity, an initial vertical velocity, all the same. Therefore, their time to that point will be the same. Good deal? What about question B? Will the magnitude of the vertical velocity of rock A be greater, less than, or equal to the vertical velocity of rock B? Why is it the same? Right, gravity, and they start the same. So it's kind of the same explanation of the blue. Both A and B begin with the same initial velocity. Turn that off. That was my spray the desk down last year alarm. The same vertical initial velocity. They have the same acceleration due to gravity. And from start to right now, they have the same vertical displacement. Make sense? The next two are real easy. We can get them real quick. Hopefully they're easy. C, will the magnitude of the horizontal acceleration of rock A be greater than, less than, or equal to the horizontal acceleration of B? It's the same. Why? Say it louder. Sorry, I got people talking in the hallway. I heard something about equal, force equal. And so once it leaves your hand, right, after you throw, that's when it becomes a projectile. While it's in your hand, it's not a projectile. So after the throw, the only thing working on each object on each is gravity. Does gravity affect the horizontal? No. AX equals 0 for both. Next question, what about the vertical acceleration? Is A greater than, less than, or equal? Equal, kind of same reason. Both have a vertical acceleration equal to gravity. Well, plus or minus, we haven't determined direction, but they both just have gravity. Good deal? All right, so next class, we're going to keep going with some concepts and start doing some math and probably get into some angle launches. We're only going to spend like 3-4 classes, I think, on 2D kinematics. And our test is going to be September 29th.